All right, so let's start talking about stoichiometry. So, stoichiometry, let's just think about this in a nice simple term. So, stoichiometry is a relationship, and that's of how much and which elements and compounds react together. This is what our chemical reaction formulas are for. So, when we had this chemical plus this chemical, that little arrow going to the other side, that is showing us a balanced equation. That balanced equation is showing us the relationship of each one of these items. So think of it like a recipe. So 2 bread slices plus 1 tablespoon of peanut butter will get me 1 sandwich. Each one of these things defines the relationship and how to make my perfect recipe. So, how do we find these relationships? Well, we look at the equation. How does each one of these things relate to each other? So, if I have 2 bread slices, I need 1 tablespoon of peanut butter. If I have 2 bread slices, I can make 1 sandwich. If I have 1 tablespoon of peanut butter, I need 2 bread slices. If I have 1 tablespoon of peanut butter, I can make 1 sandwich. If I get 1 sandwich, I must have used 2 bread slices. And if I made 1 sandwich, I must have used 1 tablespoon of peanut butter. So each one of these things can be used as a relationship. It doesn't matter how long that chemical equation is and how many things are in it. We just have to know that when we look at that chemical equation, that it's telling us the relationship of each one of those items. So let's try something out here in a second, but first I want to take a look at a BCA table. This is a way for us to organize our data. It's a way for us to organize what goes where and how much and what I'm starting with and what I'm ending with. So our before column right here, that's the amount of stuff that I'm starting with. So I like to ask people, what did you take out of the cabinets? So this is when I'm gathering my ingredients. I haven't made anything yet. The change column, so the middle, that's how much of each item I'm starting to change with, right? That's a better way to say that would be that what's being added, what's being subtracted. So on my reactant side, so the things before the arrows, those things are going to get subtracted. I'm going to use those ingredients up. I'm going to have less of them at the end. And then at the other side, the products, the things I'm making, I'm going to have more than what I started with because I'm making these things. And then the after is how much is left over. So my question for you guys is, how many cookies did you make? And then what ingredients did you use to get there? So when you're done with the reaction is what's left over after I'm done with everything, right? Recount, it's almost like taking an inventory. So let's try using one of these BCA tables to answer this question. So we're going to look at this relationship, and then we're also going to plug in our data onto this table. So you guys know how I like to read questions. So if I have 7 slices of bread, so I have 7 slices of bread, how many PB sandwiches can I make? And how much PB would I use? So I'm trying to find out 2 things. How many slices of bread can slices of sandwiches can I make? So I'm trying to figure out this. I'm trying to find out how many sandwiches I have when I'm done making things. And then how much peanut butter would I need? So how much peanut butter do I need to take out of the cabinets to figure it out? So you can always put a little star in those boxes to say, these are the things I'm solving for. Now let's pull down what information that I have. I have 7 slices of bread. So 7 slices of bread were in my cabinet. So I had 7 slices of bread before I made anything. I'm going to use it all up because I'm asking how much can I use. So I'm going to subtract 7 here, and I'm going to be left with nothing. Now, when you have a full column here, you can use this number, the whole number that's here, to figure out everything else using those relationships from earlier. Because watch, I have 7 slices of bread. I'm going to place that over 1. Now, when we look back into my problem here, for every 2 slices of bread, I make 1 sandwich. And we'll just set up our other one too. So first, if I have these 7 slices of bread again, for every 2 bread slices, I need 1 tablespoon of peanut butter. So really what we're doing is 7 divided by 2, and that's going to show me how much I need. So I grab on my calculator, I go 7 divided by 2 equals, and it's 3.5. So this must be subtract 3.5. Remember, that's my ingredients. Those are the things I'm going to be using up. And then I'm going to make a plus 3.5 because this is both the same numbers here, right? So this is 3.5 sandwiches. This is 3.5 peanut butters, right? So now I just need to start filling in the other boxes. I'm making this, so how much did I start with? When I pulled things out of the cabinet, did I have any completed sandwiches? No. So at the end of this, I must have 3.5. When I'm done with all this, am I going to use up all that peanut butter? Yes. So I must have started with 3.5. And look, we filled in those 2 boxes. We know what we have now. So now I know that I need 3.5 tablespoons of peanut butter, and I need and I'll make 3.5 sandwiches. So let's remove the idea of recipes for a second, and let's look at a different type. Let's look at this with a chemical equation. So I want to start thinking about this because this is what you're going to see. We're not going to be using sandwiches and peanut butter scoops to figure this out. So let's start reading our question. We have our equation and our BCA table set up for us, which is good. So I'm going to start underlining and circling things. So if I have 3.5 moles of H2, how many moles of H2O can I make? And how many moles of H2O do I need? So how much H2O do I need? That's a star in this box. And how much will I make of H2O? That's in this box. So similar situation. We're asking kind of a similar question. So what can we fill in? Well, before this reaction, do I have any of this water yet? No. So I don't have anything here. I can put in a 0 there to start it up. I know that I'm going to use up these 2 things, right? Because how much do I need? And I have, right? So I know I'm going to use these couple things up. So I can fill this part in, right? So let's say I have that 3.5 moles. That's what I pulled out of the cabinet. And now we can start filling in all of those boxes because we know this one has to be subtract 3.5. So if I have 3.5 moles of H2, we go back to our original equation here because these are our relationships. For every 2 H2s, I need 1 O2. And then in a similar way of doing this, so we got 3.5 moles of H2. We go back to this chemical equation. We got 2 H2s. So remember, we're still trying to cancel out these things, right? And then we have 2 H2Os. Well, right here, I can see 2 divided by 2 is 1. So I can just write across the board right here. So 3.5 moles of H2O. And then over here, this is half. So what's half of 3.5? Well, I can do it on the calculator, or this one I feel like most of you can probably do in your heads. I tend to need a calculator for myself. So 1.75. So 1.75, and that's moles of O2. And here we go. So now let's start filling it in. So that means my change here is going to be a plus 3.5. Remember, that's what I'm making. That means my after is going to have 3.5. My change here is subtract 1.75. And then lastly, that means that my number up here must have been 1.75 for how much did I need for O2, moles of O2. and how much here. So your answers are actually these two numbers as well, right at this spot. So let's look at one more. This one's slightly backwards, so we're looking at this a little bit differently. So how many moles of H2 and O2? So I need to know how much in these two columns I would need. So how many moles of this and this to make 5 moles of H2O. So when I'm done with all this, I want to have 5 moles. How much did I start with? Well, I haven't made anything yet, so I have none. So that means in this column, I must have plus 5 H2Os. Now we can start figuring things out. I know that these, I'm going to be left with nothing because I'm asking how much would I need to make this, which implies that I'm not going to have any left over. Okay. Now, in later terms, when we start doing things with limiting reactants, you will not have zeros in all of these columns down here. So just be cautious of that. Just read the question carefully. So in this case, it's fine because our moles of H2 and O2, they're going to get used up because I just want to know how much it would take to make this. Okay. So, all right, so let's look at what we have here. So I have 5 moles of H2O. All right, so 5 moles of H2O. And then we're going to do for every 2 H2Os, using my equation again, so these H2Os can cancel, I will need 2 moles of H2. For every 5 moles of H2O, I'm going to look at this. Well, my relationship is for every 2 H2Os, I have 1 O2, because it's implied that there's a 1 here, because there's nothing in front. So 5 times 2 divided by 2. So 5 times 2 is 10, divided by 2 is 5 still. So we got 5 moles of H2. So remember, everything that's on this board, everything that's on my before column here is a mole. It's an amount. I cannot put grams or anything like that on here. I can only put moles. Okay, so 5, and this is going to be half of 5, right? So we got 1 over 2, so that's half. So 5 divided by 2, that's my 2.5 moles of O2. So the H2Os cancel, I'm left with O2s, right? So we can go back to our board here. So I know that this one is going to be a subtract of 5 moles of H2, which means that up here, I must have had 5 moles of H2. And over here, so for this one, for the oxygen, so that was H2, sorry, this is O2. We're going to have subtract here, and it's going to be that 2.5 moles of O2. So this one up here must have been that 2.5 moles of O2. And again, this is my answer, and this is my answer. So record that where necessary. So that's it. We need to look at these relationships. We need to fill in this table to stay organized, and we just need to start pulling the data out. If you have any questions, like always, please shoot me an email or talk to me in class. I'm also available for extra help, so please use that. I think that once you start looking at this in a form of like a recipe, I think it's a lot easier to start thinking about these things. So how much are you using? Once you find out how much you're using, you can kind of fill in all the other boxes. All right, so have a great day, and I'm always here for help.